Hello, my name is Julie Gould and I work in the Department of Chemistry here at the University of Waterloo. Today I wanted to talk about how I've been transforming my organic chemistry labs over the past 5 years for students in chemistry, biochemistry, and medicinal chemistry programs. I hope you enjoy. Previously, my labs followed the traditional format where students would read the procedure and answer a few pre-lab questions before the lab. During the lab, students would follow the procedure, and after the lab, students would write up a lab report. As you can see, the bulk of the thinking was happening after students left the lab. Although my labs have been and still are very good at teaching students technical skills, data analysis, and working with their peers, I became increasingly concerned about what the labs were lacking. I noticed more and more that students were arriving to the lab very unprepared, following the cookbook procedure, and leaving with little to no thought about what they were doing or why they were doing it. To be fair, this wasn't entirely their fault, since the design of the lab created this atmosphere. Because students had such detailed lab procedures, they had little to no opportunity for problem solving. And when experiments didn't go as planned, students were unable to think their way through it. All of this is a disconnection from the real-life lab experience. This was the main motivation for me changing the lab model. Over time, I developed a new lab model that focused on better lab preparation and experimental understanding by incorporating more work before students arrived to the lab. One of the main focuses here was experimental design and thinking about the expected results. With better understanding before the lab, students naturally became better at problem solving during the lab and took more ownership of their results. A shift towards reflection in the post-lab allowed students to improve on their technique and design in future experiments where the same techniques were used in different applications. To implement the vision, I targeted 4 key factors. To start, I wanted students to come to the lab more prepared. The first step was to redesign the pre-lab assignments. Many of the components from the introduction and discussion portions of the traditional lab report were now part of the pre-lab assignment in a question-answer format. I also found it was very important to state the objectives and outcomes of the experiment and then reiterate them in pre-lab assignment, questions, and during the lab. Another key element was to replace the cookbook-style procedures by incorporating design. Students are now required to design some portion of their procedure as part of their pre-lab assignment. This works well because students submit their pre-lab assignments online and receive feedback before the lab period. This gives the students time to digest the feedback and make changes to their lab plan. This does require the use of various online systems such as Learn, Mobius, and Crowdmark. By removing the detailed lab procedures, an environment was created where students were able to make and correct some of their own mistakes. A simple example of this is that in many experiments, I don't tell students what type or size of glassware to use. This is very similar to a co-op or research position. I have watched students select the wrong piece of glassware, realize their mistake, and figure it out themselves. While this may seem like a small thing, in the past, students often came to me, even with these small problems. This new approach also gave students more opportunities for reflection, which simply didn't exist before. Intentional reflection has led to improved understanding and better ability in the lab much more quickly than in the past. I believe that all of these components more closely resemble the real-life lab experience. Some examples of decisions that students make in my labs can be extended to other lab courses in many different fields. For example, under Lab Tools, students can choose glassware type or size, equipment type or settings. For quantities, they could select the amount of reagent or solvent, as well as the target yield. Under Analysis, students could select the type of stain or even the type of analysis based on the experiment that they are conducting. And finally, students can design portions of their procedure, or if they are more experienced, the entire procedure for an experiment. Notice that in each of these I have written the word why underneath. I have found that when students make decisions, it is important to ask them to justify that decision. This not only helps with assessing their choices, but also helps the student to find errors themselves. It is also important to think about assessment. Think about the types of decisions students can make. Are they low stakes or high stakes in terms of safety and/or experimental outcome? Are there opportunities where tasks can be graded for completeness rather than correctness? What about the type of feedback provided? For examples, a low-stakes decision may only require guided feedback, whereas a high-stakes decision may require corrective feedback. In the lab, it is important to think about evaluating the process versus the outcome. In some experiments, the outcome may be the most important based on the learning objectives. But when I can shift the importance to the process, such as preparation and execution, students become less stressed out in the lab and open to trying different approaches. The same is true when thinking about the data acquired in the lab. How important is the quality of the data versus the data interpretation? While again, this is going to depend on the learning objectives of the lab, a shift away from the quality of the data to the interpretation and reflection of the data creates a less stressful lab environment for students and different opportunities for learning. It is a good exercise to reevaluate the alignment of a course to ensure that the assessments continue to align with the course objectives and that the teaching and learning strategies used support both. Overall, I have found that students are arriving to the lab much more prepared and are able to manage their time more effectively. They are more technically articulate, ask more thoughtful questions, and are able to analyze their data more accurately in the lab. Problem solving and decision making is occurring more naturally from what I believe to be a better understanding of the experiment and increased confidence in the lab. Because students have more ownership of their results, they are able to come up with reasonable ways to improve them. Now, from a teaching perspective, this model is much more enjoyable as it has created a more meaningful dialogue with students, both with myself and my teaching assistants. I have also had students come back after having taken all 4 of my lab courses during their 4th year research project and thank me. As an instructor, I think that this is the greatest compliment I can ask for. Thank you very much.